So I'm going to do a couple of things. First, I want to go over a few things, some of which Brianne already covered, but I think it's important stuff to talk about because I've been supervising tutors at Crosby for a number of years now, and I've come across a lot of different situations, and I just want to give you guys some insight that I've gained that can help you. And this is not just applicable only to Crosby, it's stuff that's probably applicable in most locations if you're going to work with children. Number one, first and foremost, these children are not necessarily innately built to want to learn. Kids are not necessarily going to school these days thinking, I can't wait to get in the classroom and learn today. So that means that it's our job, the classroom teacher, but then your job if you're there as well, it's our job to help them be motivated, and one of the easiest, simplest ways to do that is for you yourself to have authentic enthusiasm about what you're doing. Kids, like Brielle said, Brianne said, kids are kind of like animals in that, not that they're little animals, but in that they feed more off of the emotion that we give off than they do the actual words that we say. So I can be pretending that I'm excited about what I'm teaching, but I'm not really inside, and the kids are going to feed off of that, and they're not going to be excited about it. And if we are excited about, or at least have more of an interest in what it is we're learning, that information is retained much more than it is if you're not. If you're sitting in class and you are bored or you are annoyed or you don't want to be there, it is difficult to remember the things that are taught, correct? Is it not? If you're interested, even a little bit, it's so much easier. It almost takes no effort to walk away thinking, oh, that was so cool, he talked about this, or she talked about that, and I learned this. So if we can help the kids get in that state of mind, where there's some interest, there's some authentic enthusiasm about what they're going to learn, that's going to help them tremendously. Second thing, when we're trying to help students who make mistakes, everybody makes mistakes in what they're doing, whether you're talking about English language arts or we're talking about mathematics or any other subject. When they make mistakes, we want to do a couple of things. The first thing you want to do is do your best to actually point out something positive, something that they did correctly. Even if they messed up the whole question, they really just destroyed it. You want to find something. All right, I want to let you know that you lined up your place values really good. After that, you kind of went downhill and you made some mistakes. But that lining up is very important. So you're on the right track. You got the first step. And then you move into, okay, and all the mistakes that they made, and you try to help them. But if we can give them that first positive piece of feedback, it's going to help them be more open to learning about the rest of it when it comes along. We all feel, no matter how much we know we made a mistake, we all feel a little bit down when somebody points it out to us, even if you already knew. So we want to try to build them up real quick before we tell them, okay, but you got to fix this. So aside from that, when we're trying to help them figure out their mistakes and trying to help them do things correctly, it's very important that we not, there's two different ways we can do this, and we don't want to do one of the things, which is spoon feed them the information. We want to help them to generate that valuable new knowledge for themselves. And if you spoon feed them that information, instead of generating that valuable new knowledge for themselves, that's less likely to be retained. And you're going to hear me say that a bunch of times because really the whole field of education is all about helping people, whoever it is, students, gain valuable knowledge for themselves so that it can be retained and efficiently recalled later on. And I'm going to talk to you about recall and how to keep recall being as efficient as possible in a couple of minutes. So when we're trying to get them on task so that they're doing things the correct way instead of making mistakes, the best way to do that is to help them generate that valuable new knowledge for themselves. Well, how do we do that? How do we help them generate valuable new knowledge? Does anybody have an idea?
From mistakes.
Say that again?
From mistakes.
Well, they make the mistakes, but how do we get them on the path toward generating that new knowledge for themselves about how to do it correctly? Because they did it wrong, they've actually generated new knowledge for themselves about how to do it incorrectly. So we got to undo that. So what could be a good way to do that?
I don't know, it's just what a way to generate, maybe like encourage them, like say, what would you like to learn how to do something better?
Absolutely right.
Something like that, and that
In a
might...
way. You ask questions. You literally ask questions. The questions you're asking, though, are leading them down the correct path.
Okay.
So you can be asking questions in such a way that they're giving the answers, so they feel like they're the ones who actually came up with that information. But it's really the questioning that you did for them. And I'm going to do some of that questioning as we're going through a little bit of what we're going to do in just a minute. We're going to do a math problem in a minute. questions helps those students start to feel like they're the ones who got to that conclusion on their own. And we all know from experience that if we figure something out on our own, if we have that epiphanal aha moment, that information is far more likely to stay in our brains, be retained, and efficiently recalled later. If somebody gives us the information, it's just like the thing, the old parable where they say, if you give a man a fish, he'll eat for a day. If you teach him how to fish, he'll eat for a lifetime. We want to teach them how to learn. And so we want to teach them how to gain that valuable new knowledge for themselves. And that's really what learning is. Learning in the past was a lot of spoon feeding. And probably today a lot of spoon feeding still takes place. This is how you do it, now practice it. We want them to figure out how to do it and then practice it. And that leads us into my next step, my next piece of what I talk about. I'm going to talk about mathematics specifically, and I apologize for those people who don't like mathematics. But you possibly could walk away with a little bit of a different understanding and a little bit of a different feeling about mathematics. I get very excited about mathematics. I pretty much get excited about standing up and talking to people. But generating that valuable, or generating that authentic enthusiasm is going to help you guys, hopefully right now, experience what I want you to be able to help the students experience when you get into the classroom. So, mathematics. Specifically mathematics I'll talk about in a second, but learning in general. Is anybody in school to be in education, going to school with education? You're an education major? So you may not already, but you will be learning about something called Bloom's taxonomy, if you haven't heard about it already. Bloom's taxonomy is a theory that has an overarching theme for all subjects, not specifically mathematics. Yes?
Just paraprofessional, I just want to get used to the field because I, you know, I'm basically already had an offer at another school system, but this would be a good preparing me to work as a paraprofessional in another school system, right?
Absolutely. It will.
But as far as human services, I'm a major in human services. I guess that's considered a similar field, or would you
Some of what I'm going to teach you right now might be very valuable for you.
Okay.
So,
yeah, okay.
There's this theory, and this theory, Bloom's taxonomy, is kind of a framework for how best to approach teaching a subject to somebody so that they can go from introduction to the subject through a process that reaches mastery. Mastery being that they can efficiently recall the information later on for use, for lack of a better term, in regurgitation, on a test. And that's really what a test is, it's regurgitating information. Specifically to mathematics, there is a professor, a mathematician, his name is Dr. Mahesh Sharma. He's taught and studied mathematics in over 27 countries around the world, and he teaches workshops for educators all over the country, but specifically he teaches a lot of workshops for educators here in Berkshire County. He was the president of Cambridge College for a number of years, and he has since founded this Mathematics Institute that he runs and teaches educators how to be better mathematics instructors. And he took Bloom's taxonomy and he turned it into a 6-level approach to teaching mathematics. And he calls it the 6 levels of knowing. And his theory is that if you're able to bring a student through these 6 levels of knowing a mathematics concept, that student is far more likely to reach mastery, meaning that they will be able to efficiently and effectively recall that information for use later on. These 6 levels of knowing start with a first level of knowing called the intuitive level. The intuitive level of knowing is based on the idea of intuition. What is intuition?
Being able to let me see how I could explain it, because my boyfriend, he's very intuitive. You can read people, I guess, really well.
Kind of. Intuition is one of those words, there's a lot of them like this in our language, but it's one of those words that everybody in this room probably has a good idea of what it is, but is not able to formulate a sentence that can tell me what it is.
Yeah.
So, intuition, the intuitive level of knowing, I like to describe it like this. The intuitive level of knowing is accessing prior knowledge. When we learn information, everything that we learn, we store in our brains in something called schema. Schema is a collection of information that's all related. When you're talking to somebody and you're in a conversation with a group of people and somebody says something that is similar to something that you've experienced. Let's say you're talking to your friends and you're talking about what you did over the summer and they say, oh, I went to such and such beach and at that beach we stayed at this place. You're like, oh my gosh, in your brain, you may not want to interrupt, but in your brain, oh my gosh, I've been there and I've stayed at that same place. You're just waiting for your opportunity so you can say your experience related similar to their experience. That's intuitive level of knowing. You're storing the information they're giving you in a similar schema to the information that you already have because it's related. And we do that with everything we learn. Anytime a new piece of information is brought to our attention, we, in our brains, automatically, without even thinking about it, recall information that is similar to that so we can store it and easily recall it later on. So what we want to do for students is we want to access that prior knowledge that they have related to this topic, even if it's a new concept. And we want to help them have a better place to store that information than they might come up with on their own. It could be that they were going to store it in the exact same way, but we're just helping them. So, if we're going to teach them about adding single-digit numbers, it could be more in first grade and we're doing math facts. And we're talking about all the partners that make the number 5. The first thing we want to do is, you want to ask everybody in the room, what do you already know about adding? And they could say, adding is plussing. There's no such thing as plussing. That's not a word. But, yeah, that's excellent. You're going to do plussing. It makes sense to them, right? Adding is when you get more. Yes, that's excellent. It's when you get more of something. You're helping them store that information where you want it to be stored so that it's easily recalled. And you can throw in some terminology that's new so that they can have more information stored in that schema all related to that same topic. So the first thing you want to do is access prior knowledge, and that's simply done by asking them questions like, what do you already know about this? After the intuitive level of knowing comes the concrete. What is concrete?
Something solid.
Absolutely. It's something solid. Something you can touch, you can feel. You have proprioceptors in your fingers that send signals to your brain. If you're activating those proprioceptors, you're accessing concrete level of understanding, concrete level of knowing. So we want these students to be able to build something. This is the key to having that gaining valuable knowledge for yourselves. They're experimenting with something. Again, let's go back to talking about partners for 5. So we're trying to teach the kids all the partners that make the number 5. You might pass out counters to them. Counters with little red on one side and yellow on the other. You're going to give each one of them 5 counters, and you're going to say, I want you to divide it into 2 groups. It doesn't matter how they do it. They have 2 partners for 5, right? They've just created partners for 5 for themselves. Accessing prior knowledge and then going straight into that concrete level of knowing, building something, is getting them right on that direct path to having knowledge that they can regurgitate later on easily and efficiently. We're going to do something with the concrete level of knowledge in just a minute. I'm going to show you how that works. And it's going to require that we mess up those nice pieces of paper that you just wrote on. But that's okay. So, access that prior knowledge and then have them do something. Use manipulatives. Actually get in there and build this. After you do that, you're going to go to the pictorial level of knowledge. What's that going to mean? Now everybody's going to chime in. What's this?
How people, children or anyone forms a picture in their mind. And
Not in your mind. I'm literally talking
sorry,
about
a
picture. They're going to take whatever they just built, those counters that they just had, and they're going to draw a picture on paper that goes with it.
Sorry, I said.
No, don't apologize. It's good. So let's say that they did their first one. They had the 5 counters, and they did 4 and 1. So partners are 4 and 1. They're going to draw those same counters. If they had 4 up with red and 1 up with yellow, they're going to draw 3 or 4 circles that are going to be red and 1 that's yellow. It's going to be exactly related to what they did concretely. So we're keeping them in that exact same path. You did exactly this concretely, now you're doing the same thing pictorially. So it's always going to be the same. Whatever they did concretely needs to be drawn pictorially identically. Preferably same colors even. So if they use some kind of blocks and those blocks are different colors, you want to try to give them markers or crayons or colored pencils that are the same colors. Access the prior knowledge, build it, draw it. The next thing we're going to do is the abstract level of knowing. This is the level of understanding, the level of knowing that all of us were probably brought through for most every mathematics topic we were ever introduced to. The abstract level of knowing is the standard algorithm. It's when you divide, the first thing you do is you divide, then you multiply, subtract, bring down, and then start the process over. It's the quadratic equation. Plus or minus b squared, square root, yeah, over 4ac. Yes, it's that this is the formula, these are the steps, these are the numbers, now do it. That level of knowing is all I was ever introduced to from kindergarten all the way through taking calculus. I was never ever given any concrete, I was never ever told to draw pictures about anything. They went straight to this. This right here, going straight to that, is my personal opinion, the reason for our downfall in mathematics as a country. Kids' brains don't work the same way that they used to. Children coming up in school today don't think the same way that their parents thought or that we thought when we were in school. They need more stimulation, they need more access, they need to understand why things work. If I ever asked why, the teacher would say, because I told you just do it. It's not, there was a whole, I can't even remember what the saying was. I went to private school until 5th grade and there was a, yours is not to ask why, it's only, oh, there's a little saying that goes with it. But it was pretty much like, don't ask me why, just do it. And that was the abstract. And I just did it. But kids today, they need to know why. We need to help them understand what's behind that so they can fully comprehend and reach mastery. Mastery being that they understand fully the concept, not just the computation. Many, many, many students understand fully the computation, but not the concept behind it, myself included. I've learned so much from teaching elementary school mathematics about the concept that I didn't know before, and hopefully I'm going to be able to teach you guys a little bit about the concept of multiplication in just a minute. So, prior knowledge, build it, draw it. This is the algorithm. This is what we're all used to. From there, we get into applications. Switch it to lowercase. Applications level of knowing is this concept has an application in real life. So you're showing them how this is actually going to play out for them in real life in the real world someday. It's giving them the reason why they need to learn it. Hopefully helping them to have that innate desire to retain and not be like, oh my gosh, can you believe what he just taught me? I'm never going to use that. Forget that. Other than the test. Some of them take that seriously, but some of them don't. So applications is how does this apply to real life? If you're teaching area, you might talk to them about putting carpeting in a room. If you're talking about perimeter, it could be that you're talking about that you're going to put molding around a window. There's lots of different applications that we can bring up for students, but this is a very important step. Usually it's a pretty easy concept for them to understand until we get into the next step. The last level of knowing is communications. And this level of knowing is really more about helping the teacher, the mentor, the tutor, understand if the student has come to mastery. I like to explain communications level of knowing like this. If a student can take a concept that they've learned about, and they can explain it to another student who has no idea what that concept is about, so that that student can have at least a basic understanding, that first student has reached mastery. If you can pretty much explain this to somebody so they can start understanding it, you have mastery of that concept. You have to understand it at a level that is close to, if not at mastery, in order to teach it to somebody else. So that's what the communications level is really about. It's more about kind of a checking on their understanding. One of the ways that we do that, though, is we use word problems. So in the applications level, you might expose them to word problems that they're going to solve. In the communications level of knowing, you're going to ask that they create word problems. That's letting you know that they really understand the concept. If they can create a word problem that goes with it, as simple as, there were 5 birds in the tree and 3 flew away. How many are left? That's communications level of knowing for what concept? Subtraction, yes. That's a pretty basic skill, but a lot of kids can get through this applications, they can actually subtract. Or the abstract, they can actually subtract, but then if you have them try to write a word problem, they're lost. So if they can do that, they've reached mastery. So if a student has been able to prove to you that they have all these levels of understanding a concept, they have reached mastery. So let's try something. Let's try a concrete level of knowing. But first, I want to ask, who feels comfortable multiplying fractions? Yeah? Multiplying fractions? It's fairly basic, right? It's not super complicated. So let's start with something really easy. Let's do 2/3 times 3/4. So at this level of knowing, how do we do this?
You do the top and the bottom, right?
Correct. You add, or you multiply the numerators. So numerator is going to be 6.
Yeah.
Multiply the denominators, right? And we get 12. And then we would simplify, and it's 1/2, right? Excellent. Can any of you do that concretely? Or pictorially? Can you show me how to multiply fractions with a picture that doesn't include numbers?
With pizzas.
Can you multiply fractions with pizzas? So let's talk about the different representations of multiplication. Does anybody remember what's the first representation of multiplication? What's the first way that multiplication was explained to you? I'll give you an example. Let's say we were doing 2 times 3 equals 6.
Adds up.
How would it be explained another way?
3 to add together.
Repeated addition, exactly. 3 plus 3 plus 3, whoops, sorry. 3 plus 3 equals 6, or 2 plus 2 plus 2 equals 6, correct? That's repeated addition. But, does repeated addition work for fractions? Can I repeatedly add 2/3, 3/4 times? No, you cannot repeatedly add fractions a fraction of a time. So that representation of multiplication doesn't work for all multiplication. It works for whole numbers, great, repeated addition. It's also, though, not one of the E's that I'll tell you about later. What's another representation of multiplication? How else could I represent 2 times 3 equals 6 besides repeated addition?
We did like the charts,
A chart. Explain what you mean.
like we would have like 3 on this and 2 on that, and we'd count up how many there were.
Do you know, you're on the right track, but can you tell me what mathematics concept that's related to? So, you're saying you had 3 and 2, right? Is that what you said?
Yeah.
And you're counting up the middle?
Yeah.
What is that? Area. Area model. Area model would be, I have a rectangle, it's 2 by 3, so my area is 6 square units. And I could do the same thing this way. It's 2 by 3, and it's 6 units squared. Excellent. This can be used for this. I'll get to that in a minute. What's another representation of multiplication? You guys are rocking this. Usually I get nothing. What about this one? I'll see if you guys can tell me the name of this one. I'll even give you a hint. I have 3 groups and they are equal. Equal groups. I could also do 2 groups that each have 3 in them. Right? Equal groups. That's another representation of multiplication. Can I do 2/3 groups of 3/4? No. You can't do repeated or multiplication of fractions with equal groups. And then the last representation of multiplication is very similar to area model. It's an array. So I would go like that, or like this. And that's one step away from area model. Again, I cannot use an array for that. So how do we use the area model to represent multiplication of fractions? Well, first of all, I want you to understand that all multiplication is area of a rectangle. If you keep that in mind, it'll probably make life easier for you down the road at some point. It may not come to you now, but all multiplication is area of a rectangle. if we're going to make a rectangle to represent that, what do you think we would do? Well, let's do it.